Hi, I am Praveen. Welcome you all. In this video, I will show how to design a G+23 story building. For that, we have this much information. You can read and see what are the information given here. So let's start. Go to the file, new model. Select use built-in setting with. Here will be metric SI display units. Steel section database will be Indian, and design code for steel will be IS 800 2007, and for concrete it will be IS 456. It's okay. You see here in the X direction number of grid lines are 4, and also in the Y direction number of grid lines are 4, and each are equispaced. So grid lines in X direction 4, in Y direction 4, and spacing is 6 meter. So 6 meter, and as I said, this is 23 story building, so make it 23 number of stories, and I will use here custom story data, edit story. I am using this because you see story 1 to 8 the plan view is different, story 9 to 14 the plan view is different, story 15 to 19 the plan view is different, but 23 the plan view is different. Then such type of irregularity comes in a building or a structure, then I have to use this option. So what we will do here, I will select story 8, means I will take any extreme one as the master story. Story 8, 1 to 8 story are similar, so I have selected story 1 as master story as, and below that story all will be selected similar to story 8. And from story 9 to 14 the plan view is same, so I will again select this one as master story, and below that all the story will be similar to story 14. And 15 to 19 the buildings or story are same, so I will select again 19 as master story as so that similar to story 19. And 21, 20 and 23 are similar, so you do not to change. Press OK. Select this one, read only. Press OK. This is the plan view and this is the 3D view. So first we will define material properties. Add new material. Region will be India. Material type will be concrete. First I will define concrete. Standard will be Indian, and M40 grade is for the given data. This is M40 grade of. So press OK. OK. Again add new property. This time I will define rebar. HYSD 500 as given in question. HYSD for longitudinal, and I'll do 50 for tie bars. So OK. OK. Add new material. This time while 250. OK. 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 Again go to define. This time I will define section properties. Frame section. Here so these are the by default, so delete it. This is not for our use here, this design, so you can either delete or you can leave. Okay. Now add new property. Section shape concrete rectangular. Concrete. Since 3 beams dimension are here, and also 3 dimensions cross sections columns we have to define. So first we will define beams. First beam is 500 into 300. Material will be M40. Depth will be changed. So width will be changed. Click modify story bar. Select M3 design only beam. Select HYSD for longitudinal bars 500. For longitudinal bars, HYST 500 and confinement bars will be mild 250, and keep minimum covering 25 mm, 25 mm top and bottom. Press OK. This time I will not use add new property. I will use add copy of property, which will copy all the properties that I have defined for this beam and save our time. Add copy of property. Just I will give name 550 to 350. Just change the depth, change the width, press OK. Again I will select add copy of property, beam 600, 400, change the dimension 600, 400, press. Now all the column beams property has been defined. Now this time I will define columns property. So add new property, select this one, column size are 500 to 500, select material 40, change the depth 500, width 500, modify story bars. This time this will be PM2M3 design column. Longitudinal bars will be HYSD 500, confinement bars will be mild 250, and leave all the things unchanged. Press OK. OK. Again add copy of property, column 550 into 550, just change the depth 550, press OK. Add copy of property, column 600 into 600, change the depth 600, press OK. OK. Now go to define section properties, slab section. Please wait. So add new property, slab thickness is 150 mm, material will be M40, thickness will be 150, press OK. OK. Now we have to define material properties as well as section properties. So now go to draw, click here draw, draw beam, column, brass object, or you can select whatever you want to draw. You can select this for quick draw beams and columns, you can select this one for quick draw columns, but I am not going to this option because for that shortcut is given here. All these are the shortcuts that I will use here for our time saving purpose. So what we will do, I will select quick draw beams, but going for that I will, in the question this is given that I have to use auto select. So what we will do, go to define material properties, go to define section properties, frame section, add new property. I will select this auto select, and first I will define for beam, so I am giving its name beam auto select, and change it concrete and select all these three beams just by dragging. Add OK. Similarly add new property, auto select. This time I will do for column, so column auto select, change this to concrete, select all these three, add OK. OK. Now I will go to quick draw beams. Here I will select, since I am drawing beams auto select. But before going that, we see that I am at story 23, so I have to go to story 1, and here what we will do, click here and choose similar story, because story 1 to 8 we have similar plan view. So what we will do, just drag. But you see, up to the story 8, the only up to the story 8 beams has been drawn. Go to column, select property, column auto select, just drag. Move upward, use these two arrows to move upward. Go to what you see here, this time story 9 to 14, so go to story 14. The plan view is something different from this one. So this is the plan view 9 to 14. What I will do, I will choose this quick draw beams. Draw columns. 15 to 19 story. This is the plan view. So the 19th story. Quick draw beams. Quick draw columns. And 20 to 23. Quick draw beams and quick draw columns. Here I will now you can see this is the 3D view. So now what I will do, I have to draw slabs for all the stories. So quick draw floors, select this one, select here S150 mm. Go to bottom, means move downward. Till now we have defined and draw all the beams, columns and slabs for the entire story. Now we will define restraint, means support. So for that what we will do, just click here and go to bottom story. Now say base Z is equal to 0. What you will do, select all joints, go to assign joint restraint, click, this one is the for fixed, click here, apply, okay. So restraint has been assigned. Now the dead load and live load as per the given data we have to assign. So story for 1 to 8, dead load is 2 kN and live load is 5 kN per meter square. Both have same units, means dead load is 2 kN per meter square and live load is 5 kN per meter square. So since this unit is kN per meter square, means this is for slab. This is for slab. So what we will do, go to story 1, keep here similar story and go to assign, cell load, uniform, keep it dead load and dead load is 2 kN per meter square. This direction will be gravity. Apply. Sorry. Now we have to select. Apply. Okay. Move upward to the story 14. Again assign. So first what I am doing, first everywhere in the slab I am defining dead load. So uniform apply. Before applying, you have to select all the slabs. Don't forget to select these slabs, otherwise you will get the message, pop-up message that I have seen. So apply. Okay, then move upward, assign, cell load, uniform, apply. Sorry, again and again I am forgetting to select. So apply. Okay, move upward, assign, cell load, uniform, select this one, apply. Okay. So since dead load was 2 km per meter square everywhere, we have defined the dead load. Now come to the live load. At the top you see I am at story 20, or you can say I am at story 23, where the live load is 3.5 km per meter square from story 20 to 23. So what we will do, now I am at story 23, I will assign cell load, uniform. Here I will change to live load. I will change this value to 3.5. Apply. Sorry, don't forget to select slabs. Apply. Okay, move downward, select all slabs, assign cell load, uniform, change this to 4 because I am story I think at in between 15 to 19, and for that live load is 4 km. That's why I have given 4 km per meter square. Apply. Okay, move downward, go story 14, select all slabs, assign cell load, uniform. This value is 4.5. You see, it is story 9, from story 9 to 14. The live load is 4.5. That's why I'm using this 4.5 km per meter square. Apply. Okay, move downward. Select, assign cell load, uniform. This value will be changed to 5. Apply. Okay. So for now we have assigned all the dead loads and live loads on the slab. Now there is a cladding load 0.2 km per meter due to auto drop cladding. So this cladding load only comes to the peripheral beams except the topmost, because at the topmost there may be parapet walls or something else. So we will leave this beam, peripheral beam. Peripheral means you are not supposed to select any interior beams. So what we will do that for, first we will draw auto draw cladding. So for that we will go to draw. Here is an option auto draw cladding. Select, use floors. Okay, we will see the effect in 3D. That cladding is in a very simple language you can say cover. So you can see this is the cladding. Now the next task is to assign the cladding load of 0.2 kN per meter. So for that, go to assign frame loads, distributed load, put the value 0.2 kilonewton per meter. But for that, what we before applying, what we have to do, select all the peripheral beams. Apply. Now you can see the load has been assigned to all the peripheral beams. Now move upward. Select again all the peripheral beams. Press apply. Again move upward. Select all peripheral beams. Press apply. Select all. You have selected all peripheral beams, but here is a tricky part. So first you need to close this one. Then what you will do, you see some option is missing here. For that, what you have to do, click here. You see this is show undeformed cell. Click here. Now option is available. What you will do, click here, one story, go to the topmost, because you are not supposed to give any cladding unit at the topmost. Now you are at story 23, so what you will do, deselect this one. You can see we have deselected this one, but the other story has beam selection. So what you will do, go to assign frame loads, distributed loads. Already you can do load. Apply. Okay. So you can see that cladding load has been applied. Everything has been assigned except for wind load. What we will do, look carefully. So go to define, go to load combination. Go to define load cases. Go to define load pattern. Here give it WL wind load. Select wind and self multiplier will be 0 and auto lateral load. For that, what you will do, you select Indian IS 875 1987. Press here add new load. You see this has been added. So for that, go to modify lateral load. Here you see wind speed, terrain category, structure class, risk coefficient, topography. These are the things that you have to define. For that, what you will, I will refer to IS 875 part 3 1987. So you can see basic wind speed. Here there is a formula to calculate design wind speed Vz, which is equal to Vv into K1 into K2 into K3. Here Vz is design speed at any height, wind speed at any height in meter per second. K1 is probability factor, or what you say risk coefficient, and K2 is the terrain height and structure size factor, and K3 is the topography factor, and Vv is the Vv is the basic wind speed. And in the question it is given that the parameters that I have to consider according to Bangalore city. So For basic wind speed, what we will do, we will go to analysis, or you can go to this appendix A, where Bangalore city has 33 meter per second. You can see here 33 meter, this is the Bangalore city, and for that we have 33 meter per second. So what we will do, I will put here wind speed is 33 meter per second. Now come to the terrain category. So for terrain category, see the code. See terrain category 1, category 2, category 3 and category 4. So you will find that terrain with numerous closely spaced construction having the size of building structure up to 10 meter in height, with or without a few isolated top structures. So this is the terrain category for our purpose. So make to it category 3, and structure class, we will see for structure class. Again go to the code. For that, class A, class B and class C. So how will you find which one is? So structure or their components such as cladding, glazing, roofing, etc. having maximum dimension, greatest horizontal or vertical dimension greater than 50. Since you will find, you will see that the horizontal dimensions is 6 meter, 6 meter, 6 meter, 18 also in the x direction and in the y direction. This is the y direction. But in the vertical direction, z direction, we find 23-story buildings and each is spacing at 3 meters, so 69, which is greater than 50 meters. So this will be our class C. And the risk coefficient K1, for that you have to again go to the clause. This is the risk factor, risk coefficient for different all general buildings and structure. Mean probable design life of structure in year 50, means the design life is 50. So nothing is mentioned about this, so we will generally consider this one. And for that you will find that for this 33 meter per second wind speed, basic wind speed, K1 factor is 1. This one is 1. If suppose you get the value wind speed is between 33 and 39, say 35, then what you will do, you can interpolate. Now what you do, make it risk coefficient K1 factor 1 and topography K3 factor. For the K3 factor, what you will do, again go to the IS code, K3 factor. So terrain K2 factor is here, so K1, K3, okay. So in the code K3, no, this is not. K2 factor to obtain design wind speed variation with higher and different terrains. Yeah, so terrain category class ABC is given, and since height is more than 500 and category is class C, and for that change terrain category 1 to search. You will do you see in the clause 5.3.3 topography K3 factor, and when you come to the 5.3.3.1, you will find that the effect of topography will be significant at a site when the upwind slope theta is greater than about 3 degree, and below that the value of K3 may be taken to be equal to 1. So Supposing that the wind is speed is not greater than 3 degree, we have chosen topographic K3 1. So press now. Okay. So we have defined this window. Now what we will do, assign. Go to assign, cell load, wind pressure coefficient. So how will you give this coefficient? For that again I will refer to as 875 part 3 1986. So here you see this is a table for external pressure coefficient CP for walls of rectangular clad building. So you will find that this structure falls in this category, H by W, where H is height, which is 69, and W width 18. So 69, you can see 69 divided by 18 comes out to be 3.833, which is greater than 3 by 2 but less than 6 by less than 6. So this is the category, but the subcategory will be we have to decide whether this one or this one. So first check for this L by W. So you can see that in the X direction and Y direction, in the both direction, the dimension, the total length is 18 meters. So what we will get, 18 by 18 is 1, means you can say 1, L by W is greater than 1 or equal to 1, but it's more than 3 by 2. That means this is falling to this category. So this is a structure, you see elevation, and this is the plan view, and accordingly we have to define all the CP for structure is surface A, B, C, D, E. So and this is the wind angle, and you see for this category we will see, suppose I am supposing the wind angle is 0 degree, we will see at the surface A coefficient is plus 0.8, at the surface B at minus 0.25, at C minus 0.8, at D minus 0.8. So we have to define this. So what we will do, coefficient, but before that what we will do, close it. We will now go to elevation part. So click here elevation. So choose elevation A, apply, okay. So make here on story. So what you will get, the coefficient is plus 0.8 and the wind is hitting from this direction. This direction means windward. So what we will do, go to assign, say load, width. Software is little bit lagging or not responding. Yeah. First I have to select all the claddings at elevation. Now elevation view A. Now I am in elevation view A. So what you will see, this portion, this you can see, this is the selected all the claddings. So go to assign, say load, wind pressure coefficient. This is windward. So what I will do, the value is here plus 0.8 or you say 0.8 and windward. Apply. Okay. Similarly, go to elevation B. Here B. Here B means what? Here A, B, C, D doesn't mean that this is similar to this A, B, C, D configuration. This is somewhat different. So here we will go to B elevation, apply, okay, select all these claddings. You see this has been selected. So what we will do, assign cell load wind pressure coefficient. And what is the wind pressure coefficient for the B? This is minor wait, no, not this P1. Why I have selected here B? Because this is also for us windward direction, and for the structure you will see that this is the phase A, not the phase B in the structure. You see this is also phase A, this is also phase A for our structure. So but we have to select different elevation in this modeling purpose, so that's why I've selected the don't confuse. So put the same value because I am working on the phase A. So for A the coefficient is 0.8, for wind angle 0 degree. So put it, just press OK, apply. Now go to elevation C, apply. Oh wait, don't apply, close it. To elevation, yeah, I am at elevation you see. So again select you see you have selected this opposite faces, means leeward direction. So for that, what you see for the leeward direction is this. I am talking about this P faces. You can see very clearly in the 3D model. First we have selected this faces. I am selecting this faces which is leeward. So for the leeward, you see the coefficient is minus 0.25. So we have to put the value minus 0.25. That we will assign cell load wind pressure coefficient, put here minus 0.25 and change this leeward, apply. Okay. Wait. What happens? I think I have clicked here. That's why it is assigning this. So make it undo. It's okay. If you see that what you have assigned, I will show you. Go to elevation now, D, plan. I was working with 3D, that's why this happens. 3D, click here, elevation D, plan. For us, elevation D is also the leeward. So the coefficient will remain same. Assign cell load wind coefficient, apply. Okay. So I want to show you that what is happening there. So go to the story 1, apply. Okay, you see you are at story 1. You see this is the windward direction and this is the leeward direction. Is the coefficient right? Yeah, right. You can move to the story. Yeah, you can see. Since I have just defined the windward direction and leeward direction, so you can see everything is okay. You can check all the things. here it has not been selected. For that, what we will do, select single story, select, I have to select this one. I have to select for this we will go to elevation C. So elevation, how to control that which elevation I have to go? You see, A, B, C, D numbering is alphabetic numbering has been done, numbering has been done, and in this direction 1, 2, 3 has been done. So you see, if you are taking the section at C, you will get this. So for that you go to the elevation C, okay, sign, cell load, coefficient, line, okay. Now you will find that style, yeah, okay. So you have defined only two faces till now, A and B. Now we will go to C and D. But you see, for C and D, the coefficients are same, -0.8 and -0.8. So what we will do for C and D means this and this faces. For us in this modeling part, the section will be 1, 2, 3 and 4. And everywhere the coefficient will same. For that, what we will do, go to elevation 1, let's apply, okay. And what we will do here, we will do all story, select, and now we are in elevation view 1. Go to elevation view, go to elevation view 4, select all, go to elevation view 3, then select all, go to elevation view 2, select all, and one you have already selected. Now go to assign, cell load, then pressure coefficient, and this value is -0.8, so make it -0.8 and apply. -0.8 and press apply. Okay. Now go to plan view, say story 1, and you can see everything is okay now. So now what we will do, as per the given question, everything has been assigned so far now. So what we will do, go to analyzing part. So go to analyze. First we will check the model. Is there any error? It will be solved. Check model. Click on, select all, press OK. So wait till you get a message on the screen. Now to get model has been checked, no warning message here generated. So our model is right now okay. Close it. Now to analyze, run analysis. It will take some time. Now you see the analysis of the structure has been completed and the result are here. You can take your cursor anywhere and you will find that UX means displacement in x direction, y means displacement in y direction, and in displacement in z direction, and rx, ry, rz similarly the rotation for the moment part in the x, y, z direction respectively. And all the results can be you can see. Suppose you want to see this, click here. What you will do, suppose you click on this, display frame colors, show the function. Yeah, click this display cell stress of the forces, and you will click, you will see here the cases for dead load, live load, wind load. You can see moment for the shear force, for the reaction F1 F2 for the forces, similarly V for the shear force and for moment. So I want to see M maximum. Here show field, show line, show values. I will click this show values and apply. Wait, a little bit problem with software not responding. Yeah, you see, you can see for the dead load cases the moment value shown here. Similarly, you can see all the values. So now we will go to the design part. So for that we have to unlock this. Software is lagging a little bit, don't worry. You see, this is the diagram. You can also find control. Okay, you see, both are the same diagram. Resultant M maximum is moment maximum, and the center you are getting in the slab maximum. So you can compare this value. Also, I'm going to make this 3D. Then and for this, what I will do, go to this cell force. You can change this for wind load and you can see M1 to M11 component, this value. And you can also, and that was for the cell part, stress and forces in the, and you can also see the bending moments in the beam. So for that, what you will do, you will do, there is display frame by standard forces. Click here and case you can choose date here first. So field diagram, show value, and what is moment you want to see. So apply. Yeah, you can see the moment. You know the all the support, fixed support. So through that you will get a negative bending moment, that is at the near where the support, and positive in the center. So this is how it looks like. So you can click on any frame, you will see. You can change value for that live load. This is on the value, this is shear force value. You can drag and see all the values. and you can here put show maximum, and this is the maximum value for that particular bin that I have selected. Send this case to here. These are the things that you can do easily. So what we will do, go to the design part. But if we go to design part, making condition shapes. Design, concrete frame design, view, public, revise, preference. So IS456 2000 already selected. Press OK, will not be change. So to design, concrete frame design, select design group, select design combination. You need not to do anything. It will automatically go to design. Just go to concrete frame design, and you can see select design combination. What is showing? You see there is no combination. That means the dead load plus line load plus win load, there must be some coefficient multiplied. That is not. You will see after that it will automatic given by the subject. So go to the concrete frame design and start design check. Designing the structure is in the process. Since this is a G+23 story building, it is taking this much of time. Suppose you are modeling 100, 150 or even more, and obviously the software will take some time to design. Here CD and since software is lagging, so yeah, I think there was some problem. So what we will do, go to design and then concrete frame, select start design check. You see the progress bar. This time the design is going on. So wait till the design completed. Yeah, there is a message. Analysis and design selection differ for 705 concrete frames. Do you want to reiterate analysis and design? This is why, because the software automatically has chosen the smaller section for pins and columns that I have given. Means there is an option I have used auto select. That's why this message has been given. So I will press yes. Yeah, you can see design is good. Means the use of photo select is that software will automatically reiterate which size of the beams and column will be suitable to carry the loads. Obviously, it will take some time. You see, all the reinforcement detailing has been shown in this statement. So for this, I will close this tab. So that I can zoom it and you can see. These all the things are reinforcement details at the top and bottom. You can select anyone. You see the combination ID has been automatically created, and you can go to summary, flexure details here in yellow. So I will click here flexure details. So for that particular beam, this is the cross section. You see story 23, element B20, unique name, this is as per the software. You see all the details for that particular beam. You can see, though I have not defined the seismic rebar, but software has already given the minimum seismic rebar as per the code. So you see required rebars at the top and the bottom. Very easily you can identify and design moments, MU3 and TU, TU distortion and MU for factor moment is given this one. So these are the value you can find. And one thing that I want to show you, go to design, config frame design. Here is a display design info. You can click here. What you will see? You are seeing longitudinal reinforcement. You can see it's in percentage, reward percentage flat. You know, as per the IS 456, the minimum reinforcement in columns should be, I think, 0.8%, and in the beams it should be in tension and compression both 0.04 into the area of the cross section of the beams. So you can very easily identify that minimum reinforcing has been passed or not, and the maximum reinforcing in the column is, though code is recommended 6%, but at that it is recommended that the 6% is very high for column. You can go for 4% is sufficient. You can check very easily that 0.8, this is the minimum value that has been given here. You can also check at the bottom. You will see as you go down, the reinforcement percentage in the bottom has increased. So this is you can change whatever you want to see. There are many things here, reinforcement you want to see, whatever you want to see. Identify all failures. You can find, is there any failure? Identify all failure, place apply. Yeah, this I think red color, no get, before saying very confidently, I will, what we will do, apply here, press OK. If we go to design, complete frame design, verify all member passed, click here. All concrete frames passed the design check, means everything is okay as per the given data or as per our modeling. So press OK. Suppose go to design, concrete frame design, and display design info. Suppose any beams or any structure if fail in designing, then what you will do, you can check from here and if all failures apply. You will see there is no any red mark in the column or beams. If any beams or columns or any element fails, then it will be marked red, so need not to worry. And another way is to go to design, concrete frame design. You can verify all member past. I have already shown this part, and you can also do verify analysis for the design section. Analysis and design section match for all concrete frames. Okay, now what we will do, go to the detailing of the reinforcement. Go to the detailing preference. Oh yeah, everything is okay, whatever we want. Press. Forces you can take any kilometer, selecting the Newton, revolve it on, it's okay. And go to detailing. And here start detailing. Detailing is in progress. So yeah, detailing has been done. So you see here detailing, and go to this detailing, standard details, column section B, column section A, ABCD, you can click on them to the next color. I have to export this. Yeah. Yeah. You can similarly column section will say this is all the view. Similarly for the floor and slabs, you can see this is section A, story 23, and this is a slab details. Similarly, you can go for beams. This you see here. You can scroll the mouse cursor to see. This is the beam ID, this is the span number, and the width and depth given, and A, B, C, D, E, F, G, H is the naming different sections, and what will be the longitudinal bars that is given here. Then you can see stirrups, typical elevation, and where you will find one is only C, and for that what you have to do, yeah, this is our reinforcement KG. You can see. So from here you will go to the reinforcement case views. You can see for columns you can similarly any select anyone. You see scroll using it. This is the casing for columns that you have clicked here. So this is all about see. I want to say you. Let's try to show you something. I'm trying to complete standard details, typical concrete beam elevation. Yeah. I was trying to show you zone A. Yeah, here you can see this is zone A, zone B, zone C, zone B, C, and A, B, C, D elements. A, B, C, D, E, F, C, H, and this. So that is seeing that zombie the stack is this much. This is what you see complete. So this is all about G+23 story building, which are subjected to dead load, air load, and wind load. Be very clear. Here I have not taken consideration of the earthquake load, but the software automatically designed for minimum seismic reinforcement. So all about this G+23 story building. Thank you for watching.